welcome back to our channel. Today's class I am going to discuss about how to design EXOR and EXNOR gate by using only NOR gate. So previous videos we discussed the NAND gate and basic gate implementation using NOR gate. If you need it, kindly refer the video now, we move on the session. So let me draw the symbol of EXOR gate. So it's a EXOR gate symbol. It has a two input A and B. Y is the output. It's a Boolean expression A XOR B. So this is the elaborate expression of EXOR gate. A dot B bar plus A bar dot B. So it's a EXOR gate Boolean expression. Now we are going to implement EXOR gate by using NOR gate. So NOR gate 1, it has a two input A and B. The output of the first NOR gate is A plus B the whole bar. So it's output of the first NOR gate. So this output is transferred to input of another NOR gate. So this one is NOR gate 2. This one is NOR gate 3. So this A input is given to input of second NOR gate. B input is connected to input of third NOR gate. So here second NOR gate output is A plus B the whole bar, then whole bar. So here the input is A, second input is A plus B the whole bar. The output of the second NOR gate is A plus B the whole bar, then again bar. So here first terminal input is A plus B bar, second terminal input is B. The third NOR gate output is B plus A plus B bar whole bar. Then these two outputs are given to input of fourth NOR gate. This is the fourth NOR gate. So before applying the input fourth NOR gate, you just simplify these two expressions. So this expression is A plus B bar, then whole bar. So first you simplify this expression by using De Morgan's theorem. So De Morgan's theorem. So just apply the De Morgan's theorem here. Break the bar, change the sign. So A bar dot A plus B bar, again one bar. So this bar cancel. A bar dot A plus B. Just to multiply this term, A bar dot A plus A bar dot B. So A bar dot A 0. So already we studied the Boolean rules. A bar dot A equal to 0. So 0 plus A bar dot B equal to A bar dot B. So after simplification of this expression, you will get the result A bar dot B. So this is the input of first terminal. So A bar dot B is the input. Then come to this expression. B plus A plus B bar, then bar. So here also you just apply De Morgan's theorem. Break the bar, change the sign. B bar dot A plus B double bar. So this bar cancel. B bar dot A plus B. You will just multiply this term. You will get the result A dot B bar plus B bar dot B. So B bar dot B is 0. So already we discussed this concept. So A dot B bar plus 0. The result is A dot B bar. So after simplification of this instruction, this expression, you will get the result A dot B bar. So output of the fourth NOR gate is A bar dot B plus A dot B bar the whole bar. So A bar dot B plus A dot B bar the whole bar. So this expression look like A XOR B the whole bar. So A XOR B is called as, so A XOR B the whole bar is called as A XOR B. If you want to design the XOR gate by using NOR gate means we need 4 NOR gates is required to implement the XOR operation. But here I am going to design XOR operation. So XOR operation means I am using one more NOR gate. So this is the output Y. So A bar dot B plus A dot B bar double bar. You just cancel these two bars. You get the final result A bar dot B plus A dot B bar. So it's a XOR operation. A XOR B. If you need to design XOR gate by using NOR gate means you need 5 NOR gates. So XOR operation we need 5 NOR gate. Suppose you need to design XOR gate means we need 4 NOR gate to implement the design. So up to 4th NOR gate you will get the XOR operation. If you need to design the XOR operation means again this expression is taking complement. So after complement these two bars cancel, finally you get the XOR operation. So this is the way to design the XOR gate and the XNOR gate by using NOR gate. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make a lot of videos. Thanks for watching my channel. Thank you.